Humanity has always looked up, drawn by an innate curiosity, wondering what lies beyond the stars, pondering our place in the grand cosmic tapestry. For centuries, our tools were simple, limited by our own senses and ingenuity. Our eyes, then telescopes, each an incremental step towards a clearer picture. But even with these advancements, we were still only offering blurry glimpses of the universe. The atmosphere, a swirling blanket of gases, blurred our view, distorting the light from distant stars. It was a persistent obstacle hiding the universe's deepest secrets, obscuring the most profound mysteries. We knew that to truly understand the cosmos, we needed a clearer vantage point, a perspective unburdened by atmospheric interference. So, with audacious ambition, we built the Hubble Space Telescope, a giant leap for astronomy. Hubble transformed our understanding, revealing the breathtaking beauty and complexity of the cosmos. But even Hubble, with its remarkable capabilities, could only see so much. Its vision was limited. It primarily observed the universe mainly in visible and ultraviolet light, a relatively narrow slice of the electromagnetic spectrum. To truly glimpse the universe's first moments, to witness the dawn of creation, we needed to see in infrared, to peer through the cosmic dust and gas. Infrared light allows us to see where ancient light has stretched and shifted, a phenomenon known as redshift, over billions of years of cosmic expansion. And so we embarked on an even more ambitious endeavor. Enter the James Webb Space Telescope, or JWST, a name that will forever be etched in the annals of astronomical history. It's a revolutionary golden mirrored marvel of engineering and scientific ingenuity. JWST is meticulously designed to catch the faintest whispers of the early cosmos, the echoes of the Big Bang. In essence, JWST is a time machine, allowing us to journey back to the universe's infancy. It's peering further back than ever before, pushing the boundaries of our observational capabilities. All in the pursuit of seeking answers to the biggest questions that have haunted humanity for millennia. How did galaxies form in the early universe? What were the conditions that allowed them to coalesce and evolve? And perhaps the most profound question of all, are there other worlds like ours capable of supporting life? Perched a million miles from Earth at a gravitationally stable point in space, shielded and chilled to near absolute zero, JWST is exquisitely sensitive to the universe's earliest light, capturing photons that have traveled for billions of years. Every image it sends back is a postcard from cosmic history, a snapshot of a universe long ago. Each observation brings us closer to understanding our origins, our place in the universe. It was built to find the expected, to confirm our existing theories and models, to observe the first galaxies, the primordial building blocks of the cosmos. But the most thrilling discoveries, the ones that truly reshape our understanding, are always the surprises, the unexpected findings. And so, on an ordinary day, during what seemed like a routine observation, JWST sent back data that would upend everything we thought we knew, challenging the very foundations of our cosmological models. The universe was about to reveal a secret, a truth so profound it would change our perspective forever. Our new eyes, the James Webb Space Telescope, were about to see something impossible, something that defied our current understanding of physics, and science as we knew it would never be the same. The data arrived like any other day, another routine download from the James Webb Space Telescope. The team was ready to process the incoming information, their monitors glowing with anticipation. Little did they know, this particular data stream held a secret, a cosmic anomaly that would challenge everything they thought they knew about the early universe. Streams of numbers from deep space, cascading down their screens like a digital waterfall. Each digit, each line of code, represented a piece of the puzzle, a snapshot of the cosmos from billions of years ago. Scientists processed the data, expecting a routine calibration field, a standard check to ensure the telescope's instruments were functioning correctly. They anticipated a blank canvas, a void of nothingness against which to measure the sensitivity of their detectors, a dark, empty patch of sky, a region carefully selected for its apparent lack of any significant cosmic structures. But something was there that shouldn't be. An unexpected signal, a faint glimmer in the darkness that piqued their curiosity. At first they suspected a glitch, a common occurrence in the world of cutting-edge technology. Maybe a sensor error or software bug, a stray electron, a cosmic ray, anything that could explain the anomalous reading. Yet the anomaly persisted, stubbornly refusing to disappear with each round of diagnostics. Faint thread-like structures of light where there should have been nothing. Delicate tendrils of energy weaving a cosmic tapestry in the void. These weren't stars or galaxies, the familiar building blocks of the universe, but enormous, glowing filaments stretching millions of light-years, dwarfing even the largest galaxies. The team double-checked everything, scrutinized every line of code, but the filaments remained, an undeniable presence in the data. A longer exposure made the image clearer, revealing even more intricate details of the structure. And more shocking, the implications of what they were seeing began to sink in. The filaments were real, glowing with ionized hydrogen, a telltale sign of energetic processes at play. Arranged in a pattern that defied explanation, a complex and ordered structure that seemed impossible in the early universe. It was a colossal, shimmering web connecting proto-galaxies, the nascent seeds of future galactic empires, seeds of future superclusters, the largest known structures in the cosmos, linked in ways our models said were impossible. Connections forged in the crucible of the early universe, defying our current understanding of cosmic evolution. The universe, it seemed, had a secret network, a hidden architecture that shaped the distribution of matter on the grandest scales. Dr. Eris Thorne, the lead astronomer, a veteran of countless cosmic discoveries, described the moment as disbelief turned awe, a profound sense of wonder at the sheer audacity of the cosmos. The early universe should have been chaotic, a turbulent sea of matter and energy, with galaxies forming in isolation, scattered randomly throughout space. Instead, they saw order, a level of organization that defied all expectations. A vast structure that shouldn't exist so soon. A cosmic scaffolding erected far too early in the universe's history. It was like finding a skyscraper in a photo taken minutes after the Big Bang, an impossible feat of construction. The cosmos had just rewritten its own rules, revealing a hidden chapter in the story of the universe. So what did Webb find? Imagine the universe as a vast, dark room. Theories predicted a cosmic web, dense intersections where galaxies cluster, filaments connecting them, and voids in between. We'd seen hints of this web in the modern universe, but Webb looked back to when the universe was just a few 100 million years old. At that time, the web shouldn't have been built, just scattered villages, not highways. Instead, Webb found the Arachne filament, a glowing nexus, a downtown hub of the cosmic web already in place. Dozens of filaments converged on a single dense region, shining with energized gas and young galaxies. Something was powering this network, lighting it up across millions of light-years. It was the universe's circulatory system, seen directly for the first time. Astronomers expected primitive huts. They found a planned city. The Arachne filament was the heart of the web, pulsing with creation in an era where only chaos was expected. This discovery sent shockwaves through the astronomical community. Seasoned astronomers, experts in their fields, were left speechless. Because it didn't just bend a rule, it shattered a fundamental rule, a cornerstone of our understanding of the cosmos. It seemed to violate the very laws of physics as we knew them. The cosmic speed limit for structure formation. It's a limit imposed by the laws of physics, a constraint on how quickly matter can coalesce and form these massive structures. Gravity, the architect of cosmic structures, takes time to pull matter together. It's a slow and deliberate process. And our most sophisticated models, the culmination of decades of research, unequivocally say such massive filaments should take billions of years to form, a time frame dictated by the laws of gravity and the expansion of the universe. Yet the James Webb Space Telescope, peering into the depths of the early universe, saw the Arachne filament. It existed when the universe was less than 1 billion years old, a cosmic infant, still in its formative stages. This is a cosmic impossibility, a structure that simply shouldn't be there, according to everything we thought we knew. The standard model of cosmology dictates that small things form first, tiny fluctuations in the early universe gradually coalescing, merging over eons into larger structures, a bottom-up approach to building the cosmic web. But this filament suggests the opposite, a top-down formation scenario. The universe's largest structures, these colossal filaments of galaxies, appeared first, seemingly out of nowhere, acting as blueprints for everything else, dictating the arrangement of galaxies and the overall architecture of the cosmos. This flips our understanding upside down, challenging the very foundations of our cosmological models. With only ordinary matter, the stuff we can see and interact with. Dark matter, the mysterious substance that makes up the bulk of the universe's mass. And dark energy, the enigmatic force driving the accelerated expansion of the universe. There's no known way, within the confines of our current understanding, to build such a structure so quickly, It's like baking a cake in minutes, achieving a culinary masterpiece in a fraction of the expected time. When the recipe, based on all known ingredients and techniques, calls for hours of careful preparation and baking, are we missing a fundamental ingredient, a crucial component that we haven't yet identified in our cosmic recipe? Is there a new force at play, or a new type of particle influencing the formation of these structures? The Arachne filament forces us, compels us to reevaluate our understanding of the universe, to confront the limits of our knowledge, to acknowledge the vastness of the unknown that still lies before us. The universe may be stranger, more complex and mysterious than we ever dared to imagine, and faster, capable of processes and formations that defy our current understanding of physics than we ever imagined, holding secrets that could revolutionize our understanding of the cosmos. And now, armed with this astonishing discovery, we have to find out why, to unravel the mystery of the Arachne filament and rewrite the cosmic narrative. The Arachne filament means our cosmic rulebook needs a rewrite. The standard model of cosmology has explained much, but it can't explain this. Scientists are re-examining dark matter. Maybe it's not as cold and slow as we thought, or perhaps the universe's initial conditions weren't as smooth as assumed. Maybe patterns were imprinted from the very beginning. This discovery sends us back to the drawing board, not to discard everything but to revise the story of how the universe grew. New simulations and theories are racing to catch up. The Arachne filament is a puzzle demanding a new solution. The next chapter in cosmology has just begun. This discovery changes how we see the universe and ourselves. We once imagined galaxies as isolated islands, but the Arachne filament reveals a deeply interconnected cosmos. The highways of the cosmic web existed before the cities, galaxies, were built. These filaments channeled gas, feeding young galaxies and explaining how some grew so massive so fast. It's a cosmic ecosystem, not a battleground. The raw materials for stars, planets, and life flowed along these rivers, making creation more widespread than we thought. Our own Milky Way was likely born from such a filament. We are products of this ancient grand structure. The universe is more organized and more fertile than we ever dared imagine. The Arachne filament's discovery hit the scientific world like a thunderclap. Skeptics everywhere pored over the data, searching for errors or illusions. But every independent analysis confirmed it. The structure was real, its size and distance staggering. Doubt gave way to awe and excitement. Theorists scrambled to explain the impossible, and new ideas exploded across the field. For young scientists, it was a career-defining moment. For veterans, a reminder that the universe still holds surprises. The standard model, once settled, was suddenly wide open. Research proposals and PhD theses were rewritten overnight. The public was captivated. Headlines spoke of a cosmic ghost web and a discovery that breaks physics. The find reignited our sense of wonder and mystery. It proved that even now, the universe can astonish us. The search for answers had become a global quest, and the adventure was just beginning. The Arachne filament is more than a discovery, it's a new map for cosmic exploration. Astronomers now have a mission to find more of these filaments. Are they rare, or is the early universe filled with them? Future JWST campaigns will hunt for the faint glow of these cosmic highways, not just the galaxies they connect. This shift demands new techniques, new technology, and three-dimensional mapping. Theoretical physics will race to keep up, seeking models that explain these structures without breaking everything else we know. The filament may even link the universe's largest structures to its tiniest particles. It changes how we search for life. Two galaxies at filament hubs may be richer in the elements needed for life. The Arachne filament has given us a new chart for exploring the cosmos. The journey ahead is wide open. Sometimes a single discovery unlocks a door we never knew existed. The Arachne filament is one of those moments, a dividing line between old knowledge and a new cosmic reality. It's a lesson in humility. The universe still has the power to surprise and confound us. Our models are just approximations. The real universe is always grander. The joy of science is in finding what we didn't expect. The filament isn't the end, it's a spectacular new beginning. Our story is still being written, and we have front row seats. The atoms in our bodies were forged in stars born from such filaments. Thanks to JWST, we finally know the right questions to ask. The universe is more mysterious, more connected, and more wondrous than we ever dreamed, and our search for answers has only just begun.